Problem number 2, solve the absolute value inequality. Other than the empty set, use interval notation to express the solution set and graph the solution set on a number line. So let's write the inequality. Just like problem number 1, I want to isolate this absolute value expression first before I can think about the two cases that we usually use for absolute value. So let's get rid of this 5. Let's subtract 5 from both sides of this inequality first, just to isolate the absolute value. So that's 0. So the absolute value of 1 minus x over 2 is greater than or equal to 3. There's my inequality. That's what I'm working on solving. So to demonstrate the two cases here, just in general, if I have the absolute value of A is greater than or equal to C, this works for greater than as well. We split into two cases, and here's what our two cases look like. The first case, we remove the absolute value, so I just have A is greater than or equal to C. And then my second case, I remove the absolute value, A, change the direction. Maybe I should do that in a different color for you. Change the direction of the inequality, and then change the sign of that quantity on the right there. Those are my two cases. Those are the two inequalities I have to solve. Just in general, applying that here, and this is for absolute value greater than or greater than equal to. So my first case, 1 minus x over 2 is greater than or equal to 3. Second case, 1 minus x over 2, change the direction of the inequality less than or equal to negative 3. Those are my two cases, two equations I need to solve. So let's solve these. Can do a couple of different things. Maybe I can think about multiplying everything by 2 to get rid of that denominator there. So 2 minus 2x over 2. So greater than or equal to 6, rather. 6. So here you can see 2 times x over 2. The 2's cancel. I'm left with 2 minus x is greater than or equal to 6. Solving for x, just as I would solve an equation. Now here, I'm dividing by negative 1 to solve for x. But when I do that, gotta remember with these linear inequalities, when I multiply or divide by a negative number, I have to change the direction of the inequality symbol. See, I divided by negative 1? So the direction of the inequality must change. I'll work on solving the other side now. I'll solve it the same way. Multiply by 2 to get rid of that fraction there. Less than or equal to negative 6. That one is less than or equal to, right? So 2 minus x is less than or equal to negative 6. Subtract 2 from both sides of this equation. Negative x is less than or equal to negative 8. Again, divide by negative 1 to solve for x appropriately. So I'm left with x on the left, positive 8 on the right, but I divided by a negative number. Change the direction of the inequality symbol. So these are my solutions here. And since this came from this one absolute value inequality, we want to graph both of these solutions on the same number line. So I've got negative 4 here, and I've got 8 here. Numerical order, right? What is this at the bottom of the screen here? Get rid of that. Where'd that come from? So less than or equal to negative 4. Here's negative 4. Less than would be to the left this way. Less than negative 4. All values less than negative 4. Or equal to. So that gets a bracket. X can also be values greater than to the right. Greater than negative 8. Or equal to. Also gets a bracket. So my solution can be values here, values here. Values here satisfy my inequality, absolute value inequality. Values here also satisfy that absolute value inequality. Written in interval notation, from negative infinity to negative 4, always parentheses for infinity, bracket for negative 4. Also from 8 all the way to positive infinity, parenthesis. And I can use a U in the middle for the union, joining these two sets, these two solution sets, joining them together. So your solution for that absolute value inequality up top, any value from here satisfies it, any value from here satisfies it. There's your solution.